Welcome back. In today's video, we'll see how we can implement any given Boolean function using multiplexes. Okay. If you remember, multiplexes are nothing but MSI components, or we can say medium scale integrated components, which can be used to implement any type of function. Usually, what happens when you solve the truth table questions, from the truth table, you write the switching equations, and for that switching equation, you draw the circuit diagram using logic gates, correct? Like AND or XOR and all that. So when you have any given Boolean function and you try to implement that using logic gates, you will require a lot of logic gates in that, uh, including both basic as well as special gates. The same thing can be done with the help of multiplexers also. Multiplexers, decoders, encoders, all of them behave as uh, foundational or fundamental blocks in digital systems. So instead of always going back to the logic gates, you can always use this multiplexers and demultiplexers, encoders, decoders as building blocks to build a larger digital circuit. So in this video, we'll be seeing sorry, how we can implement any Boolean function using multiplexer. Mainly, we'll be focusing on 8 is to 1, 4 is to 1, and in some cases, I'll also show you how we can do this in 16 is to 1 marks. So here, for the first example, I've considered a three-variable Boolean function, which is dependent upon the variables a, b, and c. We'll try to implement this three-variable Boolean function first using 8 is to 1 mux, and next using uh, 4 is to 1 mux. Okay. So basically, if I'm using 8 is to 1 mux, 8 is to 1 mux, which means it has 8 inputs starting from I0, I1 up to I7. 0 to 7, total 8 inputs will be there. One output is there. And if you have a 8 is to 1 mux, 2 power 8 is equal to 3, right? 8 inputs are there and 3 select lines will be there. Okay. So you'll be having 3 select lines in 8 is to 1 mux. Let me call them as S2, S1, S0, where this is LSB, this is MSB. So if you have a three variable function, implementing it using 8 is to 1 mux is a straightforward method. So you just have to first draw the implementation table. Okay, there are different ways in which you can solve this. I'll show you one of the easiest method to implement a Boolean function using multiplexers. Okay, so now we have 8 is to 1 mux, right? You have to now draw a table such that whatever table you're drawing, it has rows and columns, correct? On the column side, you're going to have the variables which behave as select lines. Okay, on the column side, you'll be having variables which behave as select lines, whereas on the row side, you will be having variables which will be behaving as inputs. Okay, now for the 8 is to 1 mux, there is no need for any implementation table here. You can directly draw the 8 is to 1 mux. Mux, one output, and there will be 8 inputs. Okay, so call them as I0, I1, I2, I3, 4, 5, 6, and 7. And this is your output function f of a comma b comma c. And based upon the question that is given, the meaning of this question is this function of three variables will be equal to 1 for these inputs 0, 2, 3, and 7. For the rest of the numbers, the output function will be 0. Okay, so how we can write this is the numbers 0, 2, 3, and 7. That is the input 0, 2, 3, and 7. Okay, for these inputs, your output should be equal to 1, which means your input is connected to logic 1. These four inputs should be logic 1. Only then, when I do 1 plus 1 plus 1 plus 1 or operation, I will get the answer as 1. Okay, so for these four inputs, these four inputs should be connected to logic 1 so that the output can be equal to 1. The rest of the inputs you have it will be connected to ground. You can short all the other inputs and connect it to ground. Okay. So logic 1 is nothing but you will be giving it to VCC of or 5 volt. Logic 0 is nothing but you have to connect it to ground potential of 0 volt. Okay, this is how it is implemented practically. 8:1 mux is taken. On the input side, based upon the inputs that is mentioned in the question, you will be connecting it to either logic 1 or logic 0. This is very straightforward. If you're using 8:1 for 3 variable, it's very simple. Okay. Now, if I have to do the same thing, one more thing, sorry. There is also select line here, S2, S1, S0. And what you're giving here is A, B, and C. These are the 3 variables. When this ABC is 0, 0, 0, I0 will be selected and connected to the output. When this select line value is 0, 0, 1, I1 will be selected and it will be connected to the output. Okay. You know the function of multiplexer, right? At a time, only one of the input will be selected and connected to the output. The input will be passed on to the output based upon the value that is there on the select line. And you should know it is changing from 0 to 7. Correspondingly, the input number will be selected. Okay. So this is your 8:1 mux implementation. Now let's try to implement the same question, a same Boolean function using 4:1 mux. Okay. So I have the same A, B, C, summation M, 0, 2, 3, and 7. Now, when I'm using 4:1 mux, 2 power 2 is equal to 4. So I have 4 inputs and 2 select lines. Okay, so I have a 4:1 mux here, 4 cross 1. This is my output F, and 4 inputs are there in this, which I'll name them as I0, I1, I2, and I3. And 2 select lines will be there, S0 and S1. But I have 3 variables, and I can choose only 2 of them and connect them to select line, which means the third variable will be left out, and that third variable will come on the input side. Okay, so how do we decide it? Now I'll take a very simple case. Let's say I want B and C to be connected to select lines. Okay, out of A, B, C, I will take only B and C and I will put it here for select line. Then the third variable that is left out will be connected on the input side. I have to cover all the 3 variables, right? Since 4:1 mux gives me opportunity to put only 2 select lines, out of the 3 variables, I have to connect 2 of them to the select line, and whichever is left out, that will be going on the input side. Now, how do we decide how to connect this A on the input? And for that, we have to write the implementation table, right? So as I told you, the row of the table will be with respect to input. The column of the table will be with respect to select line. Since I have only one input, in this case, the value of that one input can be either 0 or 1, which means 2 possible values are there, right? The A can be 0 or A can be 1. So since you have 2 possible values, which means for this implementation table, you will be having 2 rows. Okay. Now similarly for the select line, I have B and C. If you have 2 variables, you have 4 possible combinations, 0, 0, 0, 1, 1, 0, 1, 1, which means you need 4 columns in the implementation table. So let's draw this. There are only 2 rows in this implementation table and 4 columns. Okay. So here you have this column values, which is 0, 0, 0, 1, 1, 0, 1, 1. And here you have the input value, which is either 0 or 1. Okay. So next step is, now you have to write the number inside this cell. Make sure that once you have drawn the table, totally, if it is a 3 variable three variable Boolean function, then 2 power 3. Total, how many combinations are possible? 8, correct? So you should have 8 cells in the table to cover all the 8 combinations, 0 to 7. Okay, only then your table will be correct. So you have 4 on the first row, 4 on the second row, so you have total 8 cells. Now you have to write the cell number, that is 0 to 7 cell numbers you have to mention inside this table. So how do we write it? The order in which the variable is given in the question is A, B, C. So here you read the values as it is. A value, B value, C value. Together, whatever is the decimal number, put it inside this cell. 0, 0, 0. So this becomes cell number 0. Next you have 0, 0, 1. This is cell number 1. 0, 1, 0. Binary 0, 1, 0 is nothing but decimal 2. 0, 1, 1, 3. 1, 0, 0 is 4. 1, 0, 1 is 5. 1, 1, 0 is 6 and 1, 1, 1 is 7. So you have written the cell numbers. Next step is once you have written your implementation table is ready, the next step is whichever number is given in the question, you circle them. Okay, so here 0 is given, 2, 3 and 7. Okay, so now the next step will be to write the equation for I0, I1, I2 and I3. The column value, each column value gives you the 4 inputs that is required for 4:1 mux in terms of variable A. Okay, when you're writing I0, the input equations, forget about B and C, that is select lines, only write it in terms of A. Okay, so each column gives you one input for the mux. So how do we write the input? Two things. If both the cells of that column are covered, then your answer will be 1. If none of the cells of the column are covered, then the answer is 0. If only one of them is covered, the corresponding variable should be written in the output. Okay, now we'll see for the first column, only the first row value is covered and the corresponding row value is given as 0. If I have to write A in terms of 0, this becomes A bar, right? 0 means complement format. So this first input will be A bar. Now when I come to second column, none of the cells are selected, which means the input is 0. I'm not giving any input there, it is 0. Coming to this third column, first cell is covered. First cell corresponds to A equal to 0, that is A bar. Now coming to the last one, both are covered, which means I have A bar as well as A. A bar plus A is nothing but 1. Okay, if both are covered, it is 1. If none of them are covered, then it is 0. And if single value is covered, corresponding variable should be written there. If it is 1, it will be A. If it is 0, it is A bar. So now you have all the inputs ready. You just have to write the circuit here for input side. So you can see here I0 and I2 both have the input as A bar. So I have A here, and to get A bar I need a NOT gate, and the output of this is given to both I0 and I2. I'll short them and give the input A bar to both of them. Okay. Now coming to I1, it is 0. So I'll give logic 0, I can ground it. Okay. And I3 value is logic 1, or you can give it to VCC. So this is the circuit diagram for implementing this given 3 variable Boolean function using 4:1 mux. Okay, so what did you do here? Out of the 3 variables, you have taken 2 of them as select lines, and for the remaining variable, you're using it as input. Now, to decide how to connect it to the input side, you have to use this implementation table. On this implementation table, the row represents the input variable, columns represent the select lines combination. So based on how many inputs are there, or how many variables are there for select lines, you're going to put that many rows and columns here. And then inside this, each cell, you have to represent it by the number or all the possible combinations. Okay. And then once you have written, or once your table is ready, circle the numbers which are mentioned in the question. And then each column is going to give you one of the input for the 4:1 mux. Once you have the input equations, draw the circuit diagram, and this will be the answer. Okay. So I hope this is clear. And this was very easy because you had the same order A, B, C. So writing the numbers inside this was very simple and straightforward. Now we'll try to change the select lines and see how the implementation table changes with that. Okay. So here the same function, but now I'm going to change the select lines instead of BC, I'll put some other variable for select line. Let's say I want to use A and C as select line and B will be given to input side. Now, what will be the changes in the implementation table? So, first, initial part is still the same. You have one variable on the row. So, one variable, one input for the row side. So, you have two possible values, 0 or 1. That is, since you're giving B as input, this will be B bar and B. Okay. And two variables on the select line. So, you'll have four combinations. So, A and C are used on select line. So, 0, 0, 0, 1, 1, 0, 1, 1. Now I have to write the numbers inside this. Please remember, you're taking whatever is given in the question, the order of the variable is A, B, C. Now you have to read these binary value in the same order. Don't take it as 0, 0, 0 and write 0 here. And this is not 0, 0, 1, so not 1. Okay, this is not correct. This is going to be wrong because you are reading in the sequence BAC, which is not correct. According to the question, it is supposed to be ABC. So it means I have to read A, E, C in that order and write the number. So it will be 0, 0, 0. So 0. Next is 0, 0, 1. 1, 0, 0. That is, okay, I hope this is clear. It should be in A, B, and then C. A value, then B value, then C value. Okay, what you have here is 1, 0 and B is 0. So 1, 0, 0. That is the order in which you're supposed to read the binary number. Okay, 1, 0, 0. Next is 1, 0, 1. That is 5. Okay, next is 0, 1, 0. 2. 0, 1, 1. 3. 1, 1, 0. 6. 1, 1, 1. 7. So this you have to be very careful with. Based upon what select lines you're going to use, when you're writing the cell numbers, make sure you're reading it in the proper order as that is given in the question. If you change the order, then you will be messing up with the cell numbers and your result is also going to be wrong. Okay. So I hope this is clear now, this concept. If you have understood this, irrespective of what select lines they tell you to use, you will be able to draw the implementation table and get the output from that. Okay. So now we can write the output. Each column is going to give you one of the inputs for the multiplexer. Okay, I naught, I1, I2, I3. We'll write the equation for I naught first. Before that, yes, circle the numbers that are mentioned. 0, 2, 3 and 7. So now we can say if both the cells are covered, it is B bar plus B. Both are selected. So B bar plus B is going to be 1. Here only second row is covered and corresponding value is B for I1. And the third column, none of them are selected, so answer is 0. For I3, again only the second row is selected, which is B. So I have all the inputs ready and I know what select lines I'm supposed to connect. Now I can finally draw the 4:1 mux diagram. Okay, 4 inputs and 2 select lines, which is now A and C. I have given AC, right, to the select line. When I'm drawing the diagram, I have to make sure that I've written the same variables here. This is I naught, I1, I2, I3. Now I naught is equal to 1, that is logic 1, or you can connect it to VCC. I1 is equal to B, input B. I naught is connected to 0, or you can just put it to ground like this and you can show this to VCC. I3 is also B, so I can just short it with I1. Okay, so this is the answer circuit diagram for the given Boolean function. This is how you can implement the given function using multiplexers. If it is 8:1 mux, straightforward, you have 8 inputs. Whichever number is mentioned here, connect those numbers to 1 and remaining will be connected to 0. If it is 4:1 for 3 input variables, then you will have to write the implementation table in this format and then implement it. Okay, so if you have any doubts, you can just go through the video again and you can try uh, We have done BC and AC. So I would like you to solve this given function f of a comma b comma c summation m, let's say 0, 1, 4, 6, right? And I want you to use a and b as select line, and the third variable that is left out will be given as input. So please do try solving this problem. If you have any doubts, you can leave it in the comment section. I'll be able to reach out to you, help you out. Okay, thank you.